Hello everyone. This video is about parking and how you can make vehicles wait until a car park gets empty. So by default in Vissim, just with a setting, you can change a car park to wait when it's full occupancy, but what happens is a car basically just drive up next to the car park and waits there. But you have no option to provide like a waiting area where vehicles can wait until, for example, like a drop-off area. So you can just make vehicles park until they drop off. So let me just run the model and show what happens. So as you can see, everyone is arriving. Let me just run it faster. So everyone arrives, then they wait for 2 minutes, and when the car park gets full, I stop them. And it goes for like 10 seconds more, and then I let as many vehicles in as many empty space you have. And then they will keep waiting. So how it works? First, you just place a normal car park. You can set the way you want up. There is a parking routine decision for it. This is completely normal. You set your parking duration. I'm created a new time distribution of 2 minutes. So if you go to base data, time intervals, I set distribution, time distribution, and then you just create one by clicking the plus. And you can select two different options, like a normal or empirical. It basically depends on your model, which distribution you want. I just created an empirical. In this example, it doesn't matter a lot. So it was just almost 120 seconds. Basically, to select one number between 119 and 120, so around 2 minutes. So everyone will park for that much time. There is a full occupancy behavior. You can set it to drive on, where they will just drive if there is no empty space and just carry on. And wait will make them wait. It doesn't matter in this case what you set it to. It can be drive on or anything. The way it works is I place a signal head here, and right after the signal head, that is the parking routine decision. When you use parking, you need to be absolutely sure that you have a static routing decision covering the whole distance. Otherwise, it won't work. I created a priority rule. This is important, so vehicle will wait a little bit. So the one getting to the car park, the one is parking, there is still a little bit of time for it to pass this routing and the signal head. Otherwise, vehicle will just, when they arrive at 50 km an hour, they will just drive past. So there is you can't stop them, because if the light goes red, it needs to have enough time to stop vehicles. Otherwise, they will just go through the red. So this priority rule and the settings for it depends on the speed you have in your model. So I don't have high speeds. I think I have 50 km an hour, so it's quite fast. So if your model is slower, or you put a reduced speed area here, you can make this priority rule shorter, or you can maybe even skip it. Test will show. So the way I set it up, it is maybe like a car behind up the stop line or the signal head. So 5-10 meters behind. And there is a conflict marker here. And there is a minimum clearance of 25 meters. So basically what happens is, if a vehicle comes, and if there is any vehicle within this, so the conflict marker and this triangle marks the clearance. So if I make it 20, it gets shorter. So it covers it. Just be careful that this triangle doesn't go beyond this priority rule. So you will see that vehicle will wait here as long as there is someone here, so they will just nicely go into the car park one by one. And the signal head will be red when the car park is full. A script controls it. It's parking waiting, it's a VBS script. You can see it is very, very simple. I just basically call this script as parking waiting. I define a variable, and what it does here into the signal group, I just assign this. When it says set, it means it doesn't assign the value, it basically copies this text into it. So whenever I say signal group, it equals like me saying all this. So it makes the script shorter. So here basically I could just say this whole thing, just copy paste it, but it just makes it a bit tighter and more compact and easier to understand. Then there is only one loop, a for loop. What it does, it loops through all parking lots in the system and filters down every single one of them that has in the name field for wait. I use this because you might have different car parks also in your model and you don't want to apply this script for them. So the car park you want to use for this kind of behavior, just put for wait. Or if you have multiple car parks, you can just copy paste this code multiple times and just put here what you put there. So you identify basically every car park with that. So for wait, then in the next one you will put 2 or whatever you want. It's just this text. Just you need to make sure the text matches up this one. What it does, it for each park lot, so into park lot, into a variable, puts every single car park one by one that has this name. So in our case it's gonna be just 1. Then if this park lot, so this park lot identifies one car park in each loop, but in my model there is only one. So in that one I say attribute value current available. So current availability is 0. If you go here, you can see that an attribute by default available, current availability, current bookings, current occupancy, current overbookings. So we are going to just use this current availability. So if that is 0, that means there is no more space available. Then I switch the signal state red. As you can see, Vissim.net.signal controllers item by key number 1. So the first signal controller. Within that, signal groups, item by key number 1. So the first signal group in the first signal controller 1. And within that there is one signal group. And the signal controller is just normal fixed. You need to be sure that you just set it up here and you don't put any minimum duration and you just select this red green. It's not that important, but just to make sure, and just put 0 there. And when you click here, I highly recommend to increase the frequency of the signal to 10. That means your signal controller will run in every 10th of the second. It is important, otherwise, if your vehicle speed is high, 2 can pass through the signal quite easily even. Because what it can be that this vehicle goes through, it passes the priority rule gap, occurrence, and the next one passes through before the signal goes to that. So you just make sure that you update that signal often. And even here in the script, you put a period of 10, so the signal also updates often. I select the script file. I select the simulation run. I put the function name parking waiting. That is this, that name. From time to time 0 to max, period 10. And I use runtime at time step end. It should be fine if you put the at time step start, but I think it just makes it maybe run to update it earlier, because if it changes in the start, then at the end I can make that change. So I mean, if the vehicle arrives in the start, then it will make the change in the same time step, just at the end. All right. So if you go back to the script, it puts into red, or if the availability is not 0, so that means there is space available, then I switch the signal state off the signal group. And so that means there will be nothing there, not even green. It just makes everything look nicer visually. If you go here, you can see that the signalization state is 5. But you can also say red. Probably I could just say off, but I thought I'd show you both options. So you can say red. Red, you need to make sure that it is in these brackets. 5 is an integer number, so it doesn't need to be. Here, the reason I have all these brackets, because you need to give this get filtered set as a string, sorry. But even within the string, this needs to be a string. So basically you have a string in the string. So just use the same formula or the same way if you need to do it. So like 1 bracket, 2 bracket, 3 brackets. And basically that's it. So you just put this in and you can just run the model and enjoy a good working parking lot. So as you can see, it's full now. The signal comes red. They will wait there. When we go to 120, the parking duration is about to expire. And you can see here, I show the availability. So as you can see, currently occupied 7, current available 0, currently booked 0, overbooking 0. If you allow waiting, that is the overbooking. And so now you see 2 vehicles left, so occupancy is 5 currently, and availability is 2. So 2 vehicles will go in, so currently the red goes off. And vehicles are waiting here behind. You can actually move this a bit closer, so it will be behind the vehicle, so it waits there a bit. Yeah, let's make that change. It will work, I think, with less mistakes. Let's just do this. Yeah. So I think the best way is if you put that priority rule just behind the vehicle. So I mean, not behind the vehicle, so it when it stops, so the vehicle will stop here. So the next vehicle will not reach it basically. So just make it a bit close. Yeah, like that, you see. So when it arrives here, it will need to wait. It works quite nice, I think. And thanks for watching. If you like, that would help a lot to the channel if you subscribe and like it. The algorithm will work better. If you want to support me, you can go to my Patreon page. You can find it in the description. And you can join as a member. Only cost a few dollars a month. And thank you very much for watching, and see you in the next one.